Good evening, everyone. I hope everyone is good. Everyone is fine. Just due to some technical issues, it got a bit delay. So now we are again back with the next very important chapter. I think we can say that it is the most important chapter, one of the most important chapter if you just talk about GOC and chemical bonding. So these two are very important chapters that we see in chemistry. Now we are there with the GOC, general organic chemistry. Now today what we are going to uh, suppose that how many questions we can suppose, just a minute, how many questions we can suppose every year from this chapter. I hope it is at least if you take 3, so at most it can go up to 6. So this is a very important chapter without any doubt. So let's start GOC without wasting a single second. What are these things? I hope we have to understand what are the things today we are going to study. Basically today we are going to study about practical organic chemistry, POC. Then we are going to talk about nomenclature, a very less, not much nomenclature, and we are going to talk about GOC. In GOC, what we will be talking about? We will be just talking about the electron displacement effect, and their application. That is only we are going to study about. So this is something that we will be covering today. So let's start today's session. Now, IUPAC nomenclature, I hope you all know that in any IUPAC naming of the organic compound, there are 3 parts. One is prefix, one is word root, another is, suffix, not prefix, it is suffix. Okay. Now, in the prefix, there are 2 parts. One is secondary, another is primary. Secondary tells you about the details of substituent, whatever is the substituents are there. Then primary tells you about the whatever is the nature of the chain. Is it ring or is it a straight chain? Then comes the word root. Word root tells you about the number of carbon present in the molecule. I hope you understand it. If carbon 1 meth 2 eth, I do not need to tell you. Everyone you know that. Very good. Suffix is primary and secondary. Primary tells you about the nature of the carbon bond, whether there is single bond, double bond, or triple bond. Single bond means in, double bond in, triple bond in. I hope you understand. Next, secondary suffix is nothing but it tells you about the functional group, whatever is the functional group. Let's directly come to the question solving. Now the correct structure of 2,6-dimethyl dec4-ene. Can you see that how many of the number of carbon are there in the longest number of in the longest carbon chain? It's 10. So can you see, if you see longest carbon chain, so all of them are going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of them are 10. Yes, no issues. It's okay. Now, dec4-ene. So on the 4th place, there is going to be double bond. Okay. So it is 1, 2, 3, and here it is 4. At the 4th position, there is in. For sure, it is going well. Then 2,6-dimethyl. On there is 2nd place, there is methyl, and there is 5, and there is 6. And there is on 2nd and 6th position, there are methyl. So what we can say? Dimethyl. For sure. 2,6-dimethyl dec4-ene. Option A. The first option only goes correct. Okay, next. The correct IUPAC name for the compound. This. Can you see? Whenever, first of all, there is a rule. First of all, you have to see that is there any functional group? Okay, if you see functional group, so there is double bond. Ene is also considered as the functional group. So yes, functional group is there. Once the functional group is there, then you have to think about that taking that functional group, which is the longest carbon chain. Okay, and the minimum number should be assigned to the functional group. Okay, so there is 1, 2, 3, 4, 5, 6. Either this or 1, 2, 3, 4, 5, 6. So what I will go with, if I just go like 4, 5, 6. So how many of the number of locants will be there? 1. But what if I do, or how many substituents will be there? 1. But if I go with that 4, 5, 6, how many number of substituents we are getting? 2. So we have to go to that longest carbon chain where we get the maximum number of substituents. Okay, so I think we all can see that here we are getting 2 different substituents. So of course it is the longest carbon chain that we should go with. Okay, and at what position there it is? I think it is nothing but how many number of carbon there? 1, 2, 3, 4. 3, sorry. So it is propyl. At what position it is? It is on the 3rd position. So 3 propyl. Achha, what about that? There it is 1, 2. There are 2. So it is ethyl. At what position? It is 4. So according to IUPAC, if you are naming, you have to name according to alphabetical number. So 4-ethyl, 3-propyl. 4-ethyl, 3-propyl, hex 1 ene. Not an issue. Okay, because ene is at 1st position. Okay, not a doubt. Name the compound given below. Can you see? There is these all are PYQs. You all can see that. First of all, you have to check that which is the longest carbon chain. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Is there any other possibility? 1, 2, 3, 4, 5, 6, 7. No, no other possibilities there. So let's see. So 1, 2, 3, 4, 5, 6, 7, 8. From where we should go? Let's see. If I go like that, or I can go like that. 1, 2, 3, 4, 5, 6, 7, 8. So either I can go like that, or I can go like pink, or I can go like white. So what is the rule? Rule is the minimum. You can say minimum summation of the locant. Okay, summation. Where are the locants? Or these are, one is methyl, one is ethyl. These are the two different. You can see substituents are there. So this ethyl is at which position? 5. And if you are going from white, so and here it is 6. So with white it is coming 5 plus 6, that is 11. But with pink it is coming, chalo batao zara pink se, 3 and 4. So 3 plus 4 is coming how much? 7. I hope you all can see that it is 11 and it is 7. 7 is less than 11. So what we can say? We should go with the pink number, pink, not the white. So white is wrong. Leave it. So 3 methyl and 5 ethyl. So 5 ethyl, 3 methyl. 5 ethyl, 3 methyl. Just a minute. 1, 2, 3. Sorry, not 5, 4. 4 ethyl, 3 methyl. 4 ethyl, 3 methyl, octane. How many number? Octane. Of course, it's an easy one. Next, IUPAC name of the following. There it is. Can you see there is double bond as well as triple bond? Then how will you say that which from where you have to start? Because both of them are terminal. Alkene is also terminal. Alkyne is also terminal. So always remember, alkene and alkyne. There is nothing like alkene is given more, priority. No, it is not like that. It is not about the priority. The thing is, if whenever there is priorities are same, the clash is on the basis of alphabetical order. In ene it is E, it is starting from E, but in ine it is starting from Y. So that's why we will start from here. Okay. So we'll start with 1, 2, 3, 4, 5, and 6. So it will be 5 ine and 1 ene. Can you see? So how many number of carbon are there? 6. So 1 hexene, 1 hexene, 5 ine. Option B. Next. 2 methyl, 2 butene will be presented by. I hope you all can do that. Not a big deal. 2 methyl, 1, 2, 3, 4. Not a big deal. Chalo, aage badho. IUPAC name of this. Can you see here? What is the functional group? Is there any functional group? Yes, alcohol is there, as well as here it is. What to say? There it is. Aldehyde is also there. So taking aldehyde, it should be the longest carbon chain. Okay, 1, 2, 3, 4, 5. And at fourth position there is OH. OH as a prefix, its name comes as the hydroxy. So 4 hydroxy, and ene is there at the second position. At the second position there is double bond. So 2 ene. Yes or no? And how many number of carbon there? Pent. Pent 2 ene, and for aldehyde what we use? We use al. And at what position there is methyl? 2. So hydroxy comes first, H comes first, or methyl M comes first. So hydroxy comes first. So 4 hydroxy, 2 methyl, 4 hydroxy, 2 methyl. Can you see? 4 hydroxy, 2 methyl. Pent 2 ene. Yes, it is all going also correct. 2 ene and 1 al. Of course it is correct. Option B is the correct one. Chalo aage badhenge. The IUPAC name of this. Can you see what is the functional group here? Functional group is COCl. COCl is nothing but oil halide. Oil halide. So therefore oil chloride. In oil chloride, can you see how many number of carbon are there? 1, 2, 3, 4, 5. And here it is 1, 2, 3, 4, 5. So 2 and 3. 2, 3 dimethyl. So 2, 3 dimethyl. 2, 3 dimethyl pentanoyl chloride. Not a big deal. Aage badho. Here correct IUPAC name of the following. Can you see? Here it is. What is the functional group? OH. That is alcohol. Alcohol ke liye what is the suffix? All. Can you see from where we'll start? 1, 2, 3, 4. From here we are getting 4. From here we are getting 1, 2, 3. So we have to give the minimum number to OH. Yes or no? Minimum number to OH. So we'll go like that. 4, 5, 6. So what we can say that? I hope you all can see that 1 bromo, 5 chloro, 4 methyl. 1 bromo, 5 chloro, 4 methyl, hexane, 3 all. Of course, B is the correct option. Next. Now the question is nitrogen detection in a organic compound. There comes the question from, practical organic chemistry. It comes from practical organic chemistry. That too from where? There are two types of that: qualitative analysis and quantitative analysis. Understand it. There are few points that I will be telling you. Quantitative analysis. In quantitative analysis, what are the points that you have to keep in mind? See, if let's say there is any we have to do, Lassan's test generally. In Lassan's test, we just try to first of all make a soda extract. In that soda extract, we just test through different chemicals. So always remember, let's say if there is any halide, so halide by reaction with, first of all, will react with, let's say there is Rx is there, so we react with sodium metal to convert into NaX, that is ionic, and after that we react it with AgNO3 to convert into AgX. Now AgX either may be white for AgCl, it may be pale yellow for AgBr, and generally yellow for AgI. See, I will not go much into the depth. It may take extra time. Better we will just solve question. So if there is halogen in that organic compound, it will convert into, I hope you understand, AgX. Now, if there is, let's say nitrogen is there. So if carbon nitrogen bond is there in any of the, let's say there is any organic compound where carbon nitrogen bond is there. Consider there is only carbon nitrogen bond is there. So generally what we need, carbon nitrogen bond should be present. So if it is present, it will convert into NaCN. So there is C and N, both of them will be there. Okay, cyanide, basically cyanide. What will happen with this NaCN? This is the question, that how do we go further? Next, then we react it with FeSO4, that converts into, then Na4FeCN6. Then we make it react with FeCl3, that converts into Fe, what to say, Fe4 FeCl3 whole thrice. So that whole is nothing but it is called Prussian blue. So a blue color precipitate or solution you get, that is something that is known as, what to say, test for nitrogen. So here what is the question? So nitrogen detection in an organic compound. Similarly, there is sulfur also. Sulfur converts into Na2S. Then if you made it react with lead, it will convert into PbS, that is black PPT. So similarly, it is for phosphorus, and many things are there. We'll just keep on talking as the question comes. Nitrogen detection in an organic compound is carried out by Lassan's test. Okay, Lassan's test means it is talking about qualitative analysis. So the blue color formed correspond to which of the following? I hope I have told you right now only. That is, what is that? Prussian blue. What happens? First of all, NaCN, then it reacts with FeSO4. That will convert into, I hope you all understand it, Na4 FeCN6, that is sodium ferrocyanide. Then we will make it react with ferric chloride. It will convert into Fe4 FeCN6 taken thrice. It is nothing but it is what? Prussian blue. Prussian blue के बारे में जरा देखो. Which of the following is correct? Option B is the correct option. Any issue? No. The Lassan's extract is boiled with concentrated HNO3 while testing for halogen. By doing so, what it does? Why do we add first HNO3? See, always remember. Let's say there is some impurity. You are trying to find out halogen, or let's say you are trying to detect halogen, but in the detection of halogen, let's say there is impurity of sulfur or nitrogen is also, or let's say these things are there. So sulfur and nitrogen we have to first of all remove, otherwise it will start giving the Lassan's test for sulfur and nitrogen also. What we have to do? We have to make sure that all the nitrogen and all the sulfur is removed. So to remove the nitrogen and sulfur, what we do? First of all, we make it react with HNO3. What will happen? Consider there is nitrogen is there. If nitrogen is there, what will happen? It will convert into HCN if you put HNO3 into it. And HCN is what? It is a gas. So it will just be removed. If let's say there is sulfur, then also you will put HNO3 into it. What will happen? H2S gas. H2S gas will be going out. So that is why you just put HNO3 into it to just remove sulfur and whatever is the nitrogen is there as impurity. So whatever is the remaining part, it will be only halogen, and halogen can be just given as the AgX. Yeah, right? With the help of precipitate, color of precipitate, you can easily understand what is the correct answer. Here, to decompose Na2S and NaCN if formed. Yes, of course it is correct, because once it is forming Na2S and NaCN, then only it will convert into what? HNO3 reacts with that to give HCN and H2S. Yes. Lassan's test for the detection of nitrogen fails. Always remember, where there is fails when CN bond is not present. First, and second in azo compound. In azo compounds. Why is in azo compound? Because they are unstable. Because they are unstable. So if they are unstable, consider there is azo compound. Consider if this N2Cl is there. Consider कर लो कि इसमें क्या हो गया, R है N2 plus Cl minus, कुछ ऐसा है. Now in this azo compound, if you just heat it, what will happen? Whatever the nitrogen is there in the form of nitrogen gas, it will be removed. अगर nitrogen ही हट गया तो test किसे करोगे? So therefore it does not give the test. So in azo compound, first thing is when CN bond is not present, and second thing is when there is what to say, azo compound is there. So can you see that there is nitrogen carbon bond? Yes. So it will give. So इसकी बात ही मत करो. CONNH2. No. Hydrazine. No. Let's talk about it. NH2, CONH2. Can you see that there is nitrogen carbon bond? Of course. So this will also give NH2, NH2. Can you see there is any carbon nitrogen bond? No, there is no. So option C is the correct option. Not a big deal. Easy one. Next. Here also we can see that it is NH2, NH2, C6H5. तो यहाँ पे क्या है? फेनिल हाइड्राजीन है. फेनिल हाइड्राजीन की बात मत करो, आगे बढ़ो. Next, in the sodium fusion test of organic compound, the nitrogen is in the organic compound is converted into, I hope you all remember, sodium cyanide. It converts into cyanide. So halogen into AgX, nitrogen into NaCN, that ultimately converts into Prussians blue, sulfur into Na2S, that finally converts into what to say, PbS, or let's barium sulfate also, but that is a different thing. If there is phosphorus, first of all it will be converting into, see, two things are there. First of all, we have to do give in the presence of oxidizing agent, and we have to give the heat. It converts into sodium phosphate. Then what we do, we make it react with ammonium, ammonium phosphate. What we get? Ammonium molybdate. Then if you give the ammonium molybdate, what it gives in the it gives phosphate है there, sodium phosphate is there. Sodium phosphate can be, or it can be reacted with, what to say, it may be reacted with Mg3P2O7, Mg3P2O7, Mg3P2O7. So basically magnesium pyrophosphate, magnesium pyrophosphate. Now what will this magnesium pyrophosphate? It will convert into, basically the whole magnesium sulfate will make it convert into magnesium pyrophosphate. So magnesium pyrophosphate, this phosphorus will convert into, or ammonium phosphomolybdate. So there are two possibilities are there. It may convert into ammonium phosphomolybdate, or it may convert into magnesium pyrophosphate. So these are the things that is possible. Next, Lassan's test is used in qualitative analysis to detect nitrogen, yes, sulfur, yes, chlorine, yes, all of these. Now quantitative analysis के लिए there is one rule that you always have to follow, and what is that? One formula only I'm telling you. Whatever the things for quantitative analysis, halogen will have to be converted. Consider it is the element. I'm writing few things. Element to be detected, then final substance, or final substance it got converted to. Okay, so these are the points that you have to see. Chalo dekho. So if there is halogen will convert into AgX. Okay, now halogen में कुछ भी हो सकता है, Cl, Br, I. Okay, next we are going to talk about, next one is what? Nitrogen. If there is not nitrogen here, sulfur will be converting into BaSO4, barium sulfate. Acha, what about what is this? Halogen is there, it is sulfur is done, and what is there? Can you see? Phosphorus, that will be magnesium pyrophosphate. Generally it will be giving magnesium pyrophosphate or ammonium phosphomolybdate, APM. Either it or either this, it will be given. Okay, no issues. Chalo. So what are the things that you have to keep in mind? It is the final substance. Final substance ko I will call FS. Okay, FS. So here, how do you say? What is the formula that I am giving? Always remember, percentage of element. Consider करो कुछ चीजें पहले ही मान लो कि mass of organic compound taken is given W gram, and mass of final substance obtained is W 1 gram. Okay, so what is the formula? Percentage of element, you can just say it is equals to, or you can say mass percentage of element will be equal to this mass of element in 1 mole of final substance divided by molar mass of final substance multiplied by mass of final substance obtained in gram divided by mass of organic compound multiplied by 100. So that is what you have to always follow. So it is what mass of Fs is nothing but it is what W 1 gram, and mass of organic compound is nothing but W. Can you see? Is it all understandable? Chalo, I'm taking one example for AgX. Consider karo AgCl hai, और AgCl के लिए what is the Cl? How many of the Cl is there? One Cl has the mass how much? 35.5. So how, what will be there? Percentage of chlorine will be 35.5 divided by what is the molar mass of final substance, that is AgCl, that is 143.5 multiplied by whatever is the mass of final substance, that is consider W1, and what is the mass of organic compound, consider that is W, multiply with 100, you will get the percentage of Cl. Similarly, you can go with the sulfur also. What is the molar mass of barium sulfate? That is 233. Okay, so these are the things I hope you have to understand, and it will be given also. It is 1877. It is what? It is 222. Sorry, magnesium pyrophosphate is 222, while it is what? 1877. I hope yes, it is all. So question is where is the question? Acha. So there the question is directly from for nitrogen. So you will say that, so where is nitrogen? Nitrogen ke liye there are two different methods. One is Gildas, one is Dumas method. So here the question is from Gildas method. In the Gildas estimation of nitrogen, the ammonia evolved from the 0.5 gram of organic compound neutralized 10 ml of 1 molar H2SO4. Calculate the percentage of nitrogen in the compound. देखो इसके लिए फॉर्मूला क्या है? फॉर्मूला for nitrogen in Gildas method is percentage of mass percentage of nitrogen is equals to 1.4 multiplied by whatever is the NV of what? NV of ammonia. That is what? Milli equivalents. It is not. It is what? Milli equivalents. Milli equivalents of ammonia divided by mass of organic compound. There is nothing you have to do directly. Just do this. Put this formula. Get the answer. Now, what we can say? NV of ammonia will be nothing but whatever is the ammonia that is being used, that will be equals to, because we know that NV of acid should be equal to NV of base, and here base is nothing but ammonia, and acid here is used is what? H2SO4. Can you see what is the molarity? Molarity is 1, so normality will be equal to 2. So what is that? 2 into what is the volume here? Volume taken is 10 milliliter. So what will be that? 20 milli equivalents. So what is the NV value? NV value is 20. NV value is how much? 20. So 1.4 into 20 divided by mass of organic compound is given how much? It is given 0.5. So how much it is? Cancel karo. It is 40. 40 into 1.5, that is 56%. So mass percentage of nitrogen is how much? Percentage of nitrogen is 56%. Any doubt? That is how you can solve such questions. Not a big deal. Formula हमेशा याद रखो 1.4 into NV of ammonia divided by the mass of organic compound. Next, which of the following will not give a white PPT with AgNO3 added to a solution? See, first of all, understand that these reactions are only given by, ionic changes. So wherever there will be ionic molecule, there it will be giving. So NaCl, yes, it is ionic. Yes, it is ionic. It is ionic. So if there is ionic, they will give the precipitate. But CCl4 is covalent. It is what? Covalent. So it will not give. Option A. Not a big deal. Easy. In Carius method of estimation, Carius method is nothing but for qualitative for halogen, sulfur, and all those things. Halogen 0.15 gram of organic compound gave 0.12 gram of AgBr. Okay, it is what? W1. That is mass of AgBr is nothing but it is the final substance. And what about this? This is the mass of organic compound. That is W we have considered. Find out percentage of bromine. Now, percentage of bromine will be equal to what? Remember what was the formula? I told you mass of the element in 1 mole of the final substance. In 1 mole of final substance, how much of mass of bromine is there? 1 mole of bromine has the mass. Molar mass of bromine is how much? 80. 80 divided by what is the molar mass of AgBr? You will see it is 188 multiplied by whatever is the mass of, you can say W1. W1 is given how much? It is 0.12 divided by how much is the mass initially taken or organic compound, multiplied by 100. Please do it and you will get some answer. Okay, so please check this. In a sulfur estimation, okay, now there is sulfur estimation. It is what? This much gram of organic, so it is W. Organic compound gave these many grams, so it is what? W1. Barium sulfate is what? It is the final substance. It has molar mass how much? I have told you 233. What is the percentage of sulfur? Percentage of sulfur, again same formula. In barium sulfate, how many of the sulfur is there? BaSO4. How many of the sulfur is there? Can you see? There is one sulfur is there. One sulfur has the mass how much? 32 divided by 233 multiplied by mass of final substance. That is how much? Minus mass of final substance 0.4813 divided by how much is the mass of the organic compound is there? 0.157 multiplied by 100. That is the formula. Use these things, get the answer. Not a big deal. Next, again we are going to the bond fission. Basically we have come to the GOC, the GOC part that we say general organic chemistry. In this general organic chemistry, we are going to basically study about what are the different electronic effects and their application. That is all that we are going to do. Today, isomerism, again, because it's such a big part that we cannot complete it in this part. So I will suggest please go through isomerism by yourself, where you have to study all the structural isomers and all the stereoisomers. Very important. One question generally comes from isomerism also. Please go through it. But today we are going to take those parts first of all which are more of highly weightage topics. Okay, so now so inductive effect, there are few effects that we have to always remember. Permanent effects, one is inductive effect, one is resonance, another is hyperconjugation. I will write all of them here only. Inductive, I am directly writing I M, that is mesomeric, or we also call it resonance effect, and another is hyperconjugation effect. चलो आओ जो जरा इसके बारे में देख लो. So what are the basic difference? I'm not writing all of them. I'm writing just basic difference. It is through sigma bond. Acha, it happens through sigma bond. Here electron delocalization takes place through sigma bond. It is a weak effect. It is a weak effect, and due to electronegativity difference. General things and important things. Of course, there may be two types: plus I, minus I, plus I and minus I. When it is minus I, when it is plus I, when it is going to give the electron in the carbon ring or carbon chain, while minus I, when it is taking the carbon electron from carbon ring or carbon chain. Why it is taking? Because of the more electronegativity. Why it is giving? Because of the less electronegativity. Not a big deal, easy one. Next, M or R, it is the resonance effect or also mesomeric effect or resonance effect. So how this takes place? Through pi bond d low pi, or you can say pi bonded electron delocalization. So it is a weak or strong? Very strong. It is a strong effect. Kya? How does it? Why is it strong effect? Because we know that pi bonds are weaker, so they can be delocalized easily. If they can be delocalized easily, so there the effect will be stronger. But here sigma bonds are strong, so they cannot be delocalized so easily. So therefore this effect is what? Weak. We can say yes. चलो आओ देखो, अब ये strong effect है. कितने type होते हैं? वही plus m and minus m. Where it is work? Where does it work? It works at ortho and para position in the benzene ring. Not a big deal. I am just revising. I cannot give you all the things, plus m, minus m, everything. I will tell you how to identify which is plus m effect and which is minus m effect. Groups are there. H, it is nothing but hyperconjugation. What is hyperconjugation? It takes place through or by overlap of sigma of CH alpha positioned CH bond with the pi, or we can say sp2 hybridized, sp2 hybridized carbon. So basically we'll see that where we'll see in the double bond, we'll see in the free radical, we'll also see in the you can say carbocation. Carbocation में देखेंगे, we'll see it in the carbocation, we'll see it in the double bonds, and we'll also see in the free radical. Not a big deal. आगे बढ़ेंगे, चलो चेक करते हैं कैसे काम करता है ये. So inductive effect, not a big deal. Just read these things. You can, I hope you all know that, because it is a distance dependent effect, while others like hyperconjugation and resonance are not distance dependent. Yes, one more thing, that hyperconjugation is stronger than I, but hyperconjugation is weaker than M effect. So M effect is strongest effect. चलो आओ जरा ध्यान से देखते हैं. Here, okay, leave it. Salient features of inductive effect. Inductive effect operates through sigma bond. We have studied. Partial transfer of charge takes place partial. Next, it is weak effect because it operates on sigma bond. This is a permanent effect since it depends on the permanent property, which is electronegativity. It is also called electronic or transmission effect. Not a big deal. It is very less after 2 or 3 carbon. After 2 or 3 carbon, it becomes very, very less. Now it is distance dependent. It is distance dependent. It is very important point. So always there is a rule that is distance is more important than number is more than power. So DNP rule, distance, number, power. What is that? I hope you understand. If let's say there is any minus or plus I effect group is there, if the distance, something has more distance, so it consider, so it will have the lower I effect. If something has more number, it will have higher number effect. And if something has more power, it will have higher inductive effect. But always remember, if distance is more, so it will decrease more I effect than even if the number you increase. Doesn't matter. Then second thing you will have to see number, and then last thing you will have to see power. We'll see few question if there is. Now types of I effect, that is plus I, minus I. When it is minus I, when it is taking the electron towards it, or when G is more electronegative, while here G is less electronegative, so it will give the electron density. Not a big deal. Delta negative or delta positive, delta negative. CH is considered as a standard I effect, where there we do not consider any of the electron displacement here. Now minus I and plus I effect का एक पूरा chart है. It is nothing but this chart is nothing but it is the for the electronegativity. Now you say, sir, electronegativity तो maximum fluorine का होता है, but we only study about the electronegativities of the atoms. We do not study about the whole groups. So this is nothing but, in a way, it is all the electronegativity ka chart. So what is that? Can you see? Whenever there will be something positive, so that will have least electron, or you can say it wants the electron very much. So it will attract the electron highly. So that's why they have the highest minus I effect. Can you see? Then there will be nitro is more than SO2R, then cyanide, then SO2AR, then COH, then FClBr. You all understand it? You all can see that. You all have to remember these things. These are important points. Now next one is plus I effect. Plus I effect, you also can see that whenever something is negatively charged, it will have, because the excess of electron, it will try to give the electron. So if something is negatively charged, it will always try to give the electron. So it is plus I effect rather than minus I effect. I hope you all can see that how it is all going. If let's say that R is increasing, R, that is what? That is alkyl part. If it is increasing, if the larger alkyl part is there, so its plus I effect will also be higher. That's it. Simple thing. Okay, not a big deal. You all can see that. Now D is more than H. This is something that we have to keep in mind. So if someone asks you, if somewhere let's say C T3 is there, is more than C D3 is there, is more than C H3. So if there is molar mass, if you talk about molar mass, so always remember, if higher molar mass of the hydrogen's isotopes will be there, its plus I effect will be more or greater. Next, which of the following is the strongest minus I effect? I hope you all can see that if something is positively charged, all of them are positively charged. In all of them positively charged, what we have seen, NF3 is more than, NR3 is more than. Can you see? NR3 is there, NCS3, nothing but NR3. So that is the correct option. Next, आगे बढ़ो. Now resonance. I directly come to the resonance. अब देखो इससे क्या क्या चीजें बताई जाती हैं यार. इंडक्टिव इफेक्ट से there are many things that we can say, like always remember, stability of carbocation. Stability of carbocation is directly proportional to plus I, but inversely proportional to minus I. Acidic strength is directly proportional to minus I, but inversely proportional to plus I. These things I hope you can do that. Next, basic strength is directly proportional to plus I, but inversely proportional to minus I. Or basic strength, or not basic strength, stability stability of carbon ion is directly proportional to minus I but inversely proportional to plus I. Now if stability of free radical is there, then this will also be directly proportional to plus I but inversely proportional to minus I. These things are the applications we'll see. Next, resonance ke liye, see there is lot much of theory is there, so I will not go into the theories directly. I will come for the question. What is that? Mesomeric. Due to the resonance phenomenon, there is the effect is called resonance effect or mesomeric effect. What is that mesomeric effect? Here we can just see that it is strong effect, it is subset of resonance. Okay, it is permanent effect, not a big deal. Complete transfer of electron takes place here. Why? We all know that because of the pi and whatever is the vacant p orbital and one complete filled p orbital, they start overlapping with each other, so there overlap, complete overlap of the electron, and due to the overlap complete transfer of electron takes place. Next, it operates to pi bond, not a big deal. इलेक्ट्रॉन विल चेंज इट्स एटॉमिक ऑर्बिटल, नॉट अ बिग डील, इजी है. सिग्मा से, अरे सिग्मा से अगर मान लो कोई चीज sp3 आपको दिख रही है, you may feel that CH2 minus is nothing but it is sp3 hybridized, yes or no? Because there are 3 bonds are there, 1 lone pair is there, so you may feel that okay it is sp3. So now you are feeling that what is that? sp3 orbital, hybrid orbital is there. But now because this carbon being sp2, so sp2, because of the presence of sp2, what we are happening, there is one pi bond is there, and that pi bond is nothing but it is parallel to this sp3 orbital. So one of the sp3, one p will be here, start overlapping with this one vacant p orbital, or you can say partially vacant p orbital. What it will start doing, it will, as it overlaps, it will start transferring its electron, and in such a way what will happen, there will be resonance phenomenon will start, and it's negative, because you all know that negative or positive charge, any positive charge at one center is very unstable, because it makes it very much susceptible to be attacked from any other nucleophile or electrophile. So if it is easy to be attacked, so it is very unstable. So to decrease its susceptibility to be attacked, or you can say to increase its stability, what it does, it tries to delocalize the negative or positive charge. So if something has delocalized negative and positive charge, it is going to be more stable. So for delocalization purpose, resonance is very, very important, very good phenomenon. Okay, so aa jao. So isiliye here electron will change its atomic orbital. So here from here it initially it was looking like sp3, but after the overlapping, this carbon will convert into sp2, and this electron is not just at one place, but it is revolving, or it is there, you can say delocalized in all 3 carbon. That's why we call this. Now it is distance independent. Now when jitna lamba resonance khichega doesn't matter, as long as the resonance keeps on going, its effect will be same, doesn't matter how long it is, no matter. Next, types of mesomeric effect, one is plus m and another is minus m. Plus m, that is delocalization of electron away from the group. Low. Okay, now just see that if let's say that this group is giving the electron, so therefore it is plus m. Now if something takes the electron from the, you can see that whatever is the conjugated pi system, if it takes the electron from the conjugated pi system, it will be minus m effect. Okay, so delocalization of the electron towards the group, so it is taking towards the group. Okay, understanding it. What are these effects? Always remember, if there is any atom, if let's say any atom directly attached to any carbon that is in the conjugated system, and directly attached atom has the lone pair, so it will generally show, or it will always show plus m effect. But what if the next carbon, like this example, can you see that this is the conjugated system now, or you can say that this is having pi bonded system, and it is what? It is nitrogen. Can you see this nitrogen? This nitrogen, the next just carbon after that carbon, which is the next atom, that is nitrogen, and it is having lone pair, and due to the presence of this lone pair, what will happen? This is going to show this plus m effect. Similarly for O minus, similarly OH, because oxygen also have the lone pair, nitrogen also have the lone pair. What about this OCOMe? What about this NHCOMe? Of course their plus m effect will be less. The reason being, of course it will delocalize in the pi conjugated system, but it will also give here, because there is internal conjugation is there. So due to the internal conjugation, let's say 40% it is giving here, so only 60% it can give outside, right? So that's why here plus m effect will be less. And the same thing is here also, because there is internal conjugation is there, so it cannot 100% give its electron to the conjugated system. That's why here its plus m effect is less, while their plus m effect is high. Please remember. Next is this. Let's say when you will see that minus m effect is there, minus m effect will be there when there is, let's say, plus, first of all, if there is a positively charged something is there, or second thing, let's say the first atom that we are having directly attached to carbon, if it is pi bonded, if it is pi bonded, if it is having pi bonded, in such case it will be showing minus n effect. Okay, any doubt? Next is like Cn is there, so C triple bond N. So here can you see that pi bonded? Now if it is directly attached to some other conjugated system, it will be taking rather than giving. Okay, SO3H, similarly COOR, I hope you can see that, S double bond O, double bond O, OH, here we can say C double bond O, OR. So can you see that the first atom that is here, all of them are having pi system, all of them are having pi system. Can you see? So these show minus M effect. Now in the anions HCO minus, the two carbon oxygen bonds are found to be equal length. What is the reason? Reason is resonance. Reason is resonance. Why? देखो जरा बना करके देखो, COO minus HCOO minus. Can you see? Can you see there? What is there? COO minus. See this negative charge is nothing but this is in resonance with this, you know, pi lone pair conjugation, pi lone pair. So this will be given to this, and HCO minus double bond O. Now what will be the resonance hybrid will be looking like? HCOO minus half minus half. So can you see that this is nothing but, neither this is doubly bonded, neither this is doubly bonded. This is also doubly bonded, also singly bonded. It is also singly bonded, it is also doubly bonded. So both of them, what we can say, neither it is completely doubly bonded, neither it is completely doubly bonded. So this is what 1.5 bonded, you can say that. Okay, so it is the bond order in reality. So this is also how much? 1.5. So both of them has the same bond order. So therefore bond length also is same. Bond length for both the CO is same. So what we can say, the reason is, I hope you all can understand, the CO bond is weaker than CO faltu. The anion HCO minus has two resonating structures. Yes, it is correct. So are found to be equal length. So this is the only reason. Okay, any doubt? Which of the following exhibit plus R effect? Plus R effect means something that gives the electron. Who can give the electron? That has the lone pair. Who has the lone pair? Can you see this there? N double one O. No. NO2 has a minus M effect. That too very strong. CHO minus M. OH, of course it has the lone pair. Directly bonded oxygen atom is having lone pair. Of course it is. Now hyperconjugation. What is hyperconjugation effect? Hyperconjugation के लिए हमेशा याद रखो, कुछ नहीं ज्यादा सोचना है. Whenever there is any, let's say, doubly bonded positive charge, or there is any free radical, just see that alpha carbon. If alpha carbon has the alpha hydrogen, it will show the hyperconjugation effect, and it will increase the stability of the alkene positive charge, or we can say that free radical. Okay, now hyperconjugation involves the movement of sigma bonded electron pair, that is sigma electron, which is conjugation to an unsaturated atom. Usually the sigma electrons of the CH bond alpha 2 sp2, see, alpha 2 sp2 hybridized atom are involved into, basically this is very important, usually the sigma electrons of the CH bond where C is carbon is sp3 hybridized are involved in hyperconjugation. It is also called no bond resonance, or effect is sigma pi conjugation or Baker-Nathan effect. How it looks like? Can you see that this is the carbon, this is the pi conjugated system? Can you see this carbon is alpha to this, yes or no? Alpha. How many hydrogen are there? 3 alpha hydrogens are there. So all 3 alpha hydrogen will be there in hyperconjugation. So what will happen? This CH bond is there, na? Though it is sigma bonded. So what it will do? It will start overlapping with the pi orbital here. Whatever is the pi orbital is there, it will start overlapping with it. Once it's overlapping with start, what will happen? Some of the electron density will be given inside. As it will be given inside, what will happen? The electron will be going there. Just to understand it, how it is going, just same as resonance, whatever we do. Similarly, hyperconjugating effect will also work. What do Dave do from here? There are few things that you have to keep in mind. With those, better we just go with the question. Which of the following is most stabilized by hyperconjugation? Always remember, stability is directly proportional to alpha hydrogen. ठीक है, आओ जरा ध्यान से देखो. Is there alpha hydrogen here? Yes. Alpha carbon is there? Yes. How many of the alpha hydrogens is there? 3. So how many? 3 alpha hydrogen. How many are here? Here are, because it is alpha carbon, so there are 2 alpha hydrogens. Can you see here? Here it is 1 alpha hydrogen. How many are there? 0 alpha hydrogen. So what it is asking, more stabilized by hyperconjugation will be A. Any doubt? No doubt. number of hyperconjugation structure in isopropyl radical is. Can you see what is isopropyl radical? Isopropyl radical matlab C CH3 CH3 isopropyl. Now make it radical. Can you see, is there alpha carbon here to this radical? To this radical, is there any alpha hydrogen? Yes, there is one. 2 alpha carbons are there. So how many of the alpha hydrogens are there? 3 alpha hydrogen here and 3 alpha hydrogens here. So total alpha hydrogen will be 6 alpha hydrogens are there. So how many of the hyperconjugation structures will be there? Please keep in mind. Please keep in mind. Hyperconjugation structure equals to number of alpha hydrogen. If it is asking for total number of total number of hyperconjugation effect, hyperconjugation structure, taking even the bonds of CH bond. If you are considering CH bond also intact, so there will be whatever is the alpha hydrogen plus 1. Though it is not giving like that, so it is directly asked. So how many of the alpha hydrogens are there? 3, 3, 6. So how many of the hyperconjugating structures will be there? 6, because it is equal to number of alpha hydrogen. Okay. Hyperconjugation occurs in wherever there will be alpha hydrogen to double bond. Is there double bond? Yes. Is there alpha carbon? Yes. In this alpha carbon, is there any alpha hydrogen? No. No alpha hydrogen. Alpha carbon is there, but alpha hydrogen is not there. So where hyperconjugation occurs? No. Here it will not occur. What we can say that this is something here. Alpha carbon is there. Alpha hydrogen is also there. Yes. Option B will there. Can you see pH CH double bond CH2? Can you see that pH is there? So it is to next carbon. It will be something looking like this CH double bond CH. Can you see this alpha to this carbon? This carbon, does it have any hydrogen? No. Anyways, this carbon is not sp3 hybridized, so do not think about it because it is sp2 hybridized. So do not think even about that. No, it will not show. CH3 plus. It is only one carbon. So where is the alpha carbon? No. So only B is the correct option. Next, heat of hydrogenation. Always remember heat of hydrogenation. Heat of hydrogenation is equal to the number of the pi bonds. First of all, it is equal to the number of pi bonds. The more the pi bonds will be there, the more the heat of hydrogenation will be there. But if the number of pi bonds are same, first things always keep in mind. So heat of hydrogenation is directly proportional to number of pi bonds. And second thing is that heat of hydrogenation is inversely proportional to stability. If number of pi bonds are सेम. कंसिडर करो कि कहीं पर अगर नंबर ऑफ अल्फा हाइड्रोजन सेम आ गए तो क्या करोगे, और यू कैन से नंबर ऑफ, लेट्स से दैट हियर नंबर ऑफ पाई बॉन्ड्स आर सेम, तो ऐसे केस में क्या करोगे कि you will see the stability. And stability कैसे देखोगे? You all know that stability is directly proportional to number of alpha hydrogen. So please keep in mind. So what we can say, HOH is inversely proportional to number of alpha hydrogen. क्या ये बात पक्का समझ में आ रही है? So because alpha hydrogen will give the hyperconjugation effect. Hyperconjugation effect. Due to hyperconjugation, what happens? Because whatever is the charge or there, or whatever is the something is there, that gets delocalized, and due to delocalization of charge and a destabilizing factor, so that decreases. चलो भाई आगे जरा देखते हैं. Now heat of hydrogenation is there, not a big deal, कर सकते हो. सीधा क्वेश्चन पे आएंगे. Same thing for heat of combustion. Think about heat of combustion. Heat of combustion की बात करोगे तो always remember one thing, that heat of combustion is directly proportional to number of carbon in the molecule. Second thing is heat of combustion is inversely proportional to stability. If number of carbon is same. Number of carbon is same. And we all know that stability is directly proportional to alpha hydrogen. So therefore what we can say, heat of combustion is inversely proportional to number of alpha hydrogen. Any doubt? I think no doubt. चलो आओ भाई देखते हैं What is there? 2 hexene and 1 pentene. How many number of carbon are there? C6, and here it is C5. So of course hexene will be more than pentene. Any doubt? Of course it is correct. Next, here what we can say, how many of the number of carbons are there? On the basis of number of carbon, you can see that more number of carbon, less number of carbon, least number of carbon. What we can say, it will be more than this, is more than this. What we can say here, this is more than, this is more than, this is more than this. I hope you all can see that. Again here it is more number of carbons are there. Chalo bhai, aage badhenge. Next, hyperconjugation occurs. But let's say if someone asks you in this question, fourth question, that where the heat of combustion per carbon is more. So if you talk about per carbon, you will have to see the strain. Where the strain is more, angle strain is most in this, then this, then this, and minimum is here. Minimum in cyclohexane. Due to cyclohexane has minimum angle strain. So what we can say that here per carbon, because its stability will be more. So as the stability becomes more, per carbon its heat of combustion will be less, but overall heat of combustion will be more. Understanding it? Overall it is more. Why? Because the number of carbon is more. That's it. But per carbon it will be less. I hope you understand it. Not a big deal. आगे बढ़ोगे. Hyperconjugation occurs in. Can you see? Is there any alpha carbon? Yes. Alpha hydrogens are there. Yes. बिल्कुल. Of course here hyperconjugation will occur. अरे ये तो यहाँ भी होगा. Hyperconjugation occurs in. Double bond. यहाँ पे भी होगा. So B. Double bond. Here also it will happen. Acha, all of these. Option D. Next, hyperconjugation occurs in. Is there any? No, because there is no alpha carbon. Is there alpha carbon? Yes, alpha hydrogens are there. Can you see how many of the alpha hydrogens are there? 9 alpha hydrogens. So B and C both are there. So option D will be the correct option. Next, आगे बढ़ो. How many of the hyperconjugable hydrogen atoms does this compound has? How many of them are there? Can you see double bond? Now how many of the double alpha positions are there? 1, 2, 3, 4. 4 alpha positions are there. How many of the alpha hydrogens are there? Can you see? Chalo, let's find out. 3 alpha hydrogen here, 3 alpha hydrogen are here, 2 alpha hydrogens are here, and 2 alpha hydrogens are here. So what we can say that 3, 3, 2, 2, 10. Overall, how many of the hyperconjugable hydrogens are there? I hope you can see that 10 are the correct answer. Among these compound, which of the following order is correct for their no bond resonance? No bond resonance is nothing but it is hyperconjugation energy. Hyperconjugation energy is directly proportional to extent of hyperconjugation. Extent of hyperconjugation is directly proportional to number of alpha hydrogen. Any doubt? No doubt. I feel. चलो आओ भाई देखते हैं. So how many of the alpha hydrogens are there? Can you see? There are 2 here, 2 here. So because there are 2 alpha position, 1, 2. Can you see? Now, so how many of the alpha hydrogens are there? 4 alpha hydrogen here. Can you see here? How many of them are there? 3 here, 3 here, 2 here, 2 here. So there are 10 alpha hydrogen. Can you see in this? So what are the alpha positions? 1, 2, 3. 3 alpha. Here how many of the alpha hydrogens are there? 2. Here how many are there? 3. Here how many are there? 1. 3, 1, 4, 2, 6. So 6 alpha hydrogens. Can you see? Is the number of carbon same in all of them? अरे यार छोड़ो. सीधा इसने पूछा है hyperconjugation energy. Hyperconjugation energy is directly proportional to extent of hyperconjugation is directly proportional to number of alpha hydrogen. So because here second is most, so 2 is more than 3 is more than 1. 2 is more than 3 is more than 1. So 2, 3, 1. Any doubt? No doubt. आगे बढ़ो. Which of the following order is correct for the heat of combustion of these isomeric alkenes? Isomeric alkenes means, can you see how many number of carbons are there? The number of carbon in all of them is going to be same. Always remember, whenever this is going to be in the same side. So this is going to be most stable. It is going to be most stable. So what is this? This is going to be, though you'll say that sir, यहाँ पे भी there is 6 alpha hydrogen. यहाँ पे भी there is 6 alpha hydrogen. यहाँ पे भी there is 6 alpha hydrogen. Always remember, this is going to be, if both of them are at the same side, it is going to be most stable. ठीक है, कोई दिक्कत? तो ये तो सबसे stable हो गया, first one. Now in second and third, because we can see that this is cis and there it is trans. So because trans is going to have the less repulsion. Here it is going to have it is going to have more repulsion. More repulsion will be having less stability. Here it will be more more stability. Always remember key trans is going to be more stable than cis is going, or this is going to be stable, more stable than both of them. So 1 is more than 3 is more than 2. 1, 2, 3. 1 is more than 3. 1 is more than 3 is more than 2. 1 is more than. So what it is asking? Acha, stability. So because we are writing stability, that is 1 more than 3 more than 2. So what it is asking for? It is asking for heat of combustion. Now heat of combustion is inversely proportional to stability. So therefore heat of combustion will be just opposite, means 1 less than 3 less than 2. So 2 is maximum, 2 is maximum, 2 is maximum, 3 1. Option D. Next we are going towards which of the following order is correct for the heat of combustion of these isomers. Again you can go with the same thing because stability ke just opposite. Stability ke just opposite. So can you see it is what? Can you see it is benzene, and benzene, everyone we know that benzene is what? It is not just resonance stability, it is aromatic. It is aromatic because we know that aromaticity gives the maximum stability. Aromaticity gives maximum stability. Maximum stability. So what we can say? Can you see कि यहाँ पर aromaticity है जबकि यहाँ पर क्या है? सिर्फ conjugation है. तो यहाँ पर due to conjugation, stability will be not as much as it is here. Okay. So what we can say that? So here, anyways, number of pi bonds also you can see that how many of the pi bonds are there? 1, 2, 3, 4. So how many of the pi bonds are there? 4. So anyways, it is going to have, you know, heat of more heat of combustion. Okay, it is asking about heat of combustion. Number of carbon is 6 here also, or number of carbon 6 here also. But we all know that because heat of combustion is inversely proportional to stability, and it is exceptionally stable. So iska heat of combustion will be less. So it has less heat of combustion, while here it is more heat of combustion. चलो भाई, तो 1 2 is more than 1. Option B. चलो आगे बढ़ो. Which of the following order is correct for heat of hydrogenation of this compound? I hope again you can see that where the number of alpha hydrogens are more. Such kind of question, I hope you all are very easily now you can do that. Okay, again I'm directly doing here 10 alpha hydrogen. Can you see 6 4? Here how many are there? Alpha carbon 1 2. So it is 3 alpha hydrogen. Can you see here 2 2? So 4 alpha hydrogen. Can you see? So most stable is this. It is asking for heat of hydrogenation. Now you know that heat of hydrogenation is just opposite. So 1 will be minimum and 2 will be maximum. 2 is more than 1 is more than 3. 2 is more than 1 is more than 2 is more than 1 is more than 3. Just a minute. 2 is more, sorry, 2 is more than 3 is more than 1. 2 3 2 is more than 3 is more than 1. Option 1. Why? Because its stability is maximum. Stability is maximum. ये बात सबको समझ में आ रही है? चलो आगे आओ. Which of the following second ions is more stable than first? Okay, means second means this one. Chalo dekho. Here can you see that what is something that is happening here? So here it is negative charge. Here it is what? NO2. What will happen here? NO2 is there and here it is CH2 minus. So NO2, even if you go by the minus I, so minus I of NO2 is more than fluorine. So we all know that stability of carbon ion is inversely proportional to, or sorry, directly proportional to minus I effect. So minus I effect is stronger. So because both of them has the same distance, so you will see that the power directly, distance is more than, number is more than power. Number is also 1. Here also how many fluorine is there? How many of the nitro is there? 1. So what will be working? Power. So where the power is more, nitro has higher power of minus I. So here minus I is stronger, यहाँ पे minus I is weaker. So option A is the correct option. Any doubt? No doubt. आगे आ जाओ. CF3 minus and CL3 minus. अच्छा, what it is asking for? Second is more stable. No. Here though, first one is more stable. CF3 is more than CCl3 minus. चलो देखो, अब ऐसे तो तुम सोचोगे F has higher minus I than Cl minus. No, but you will not have to think out in this term. Always remember this is the case of back bonding. Back bonding. What happens in C, F, C, F, F, and what about C, Cl, Cl, Cl? if it is having negatively charged. If it is negatively charged, because fluorine is what we can say that fluorine has the octet complete. Fluorine has the octet complete. It has no, it has nothing to take from it. But what about this chlorine? Chlorine has the vacant d orbital. What is that? Vacant d orbital. And due to presence of vacant d orbital, it keeps on donating its negative to the vacant d orbital of these chlorines. So therefore, what happens? This negative charge gets delocalized, and due to the delocalization, its stability increases. As the stability increases, what we can say that this is more stable. So second is more stable. So which of the following is second anion more stable? So option B. Always keep in mind. Very important. Now next, all of them you can see that CF3, CCl3, because CF3 is higher minus I, CaCl3 is lower minus I. So this will be, first will be more stable. What about this CS3, CS2, CO minus? Can you see that it is what is happening? Here resonance will be taking place. Due to resonance, it is very stable. While NH2 minus, what is there? It is, you can say that minus I is there, just minus I is there. Do not think about plus M, because here there is no conjugation in such a way, because there is lone pair and it is also lone pair. Lone pair वो भी अगल बगल से नहीं हो जाएगा, ठीक है? तो बात समझ लो कि यहाँ से क्या हो रहा है? It is going to be minus M effect. Minus M effect से first is going to be more stable. So it is more stable. It is more stable, but only here in B, second one is more stable. Arrange them in decreasing order of acidity. Now about acidic strength, we have to keep few things in mind. Acidic strength is directly proportional to Ka, inversely proportional to pKa. Acidic strength is directly proportional to stability of conjugate base. Conjugate base बना लो, उसकी स्टेबिलिटी देख लो. स्टेबिलिटी के लिए फैक्टर तुम्हें पता है, that I effect, M effect, R effect or H effect. Okay, these things are there. Now acidic strength, these things always keep in mind, very important. And acidic strength is directly proportional to electron withdrawing effect, but inversely proportional to electron donating effect. Electron donating effect मतलब positive, electron withdrawing means negative effect. तो directly proportional to negative effect, but inversely proportional to positive effects. चलो आओ जरा ध्यान से देखो. There is phenol, there is phenol, there is phenol, there is phenol. Phenol is acidic or not? Yes, it is acidic. Yes or no? Now in acidic strength, few things always you have to keep in mind कि सबसे ज़्यादा कौन हो जाता है? Let's say if there is SO3H is there, RSO3H will be, जहाँ पे भी देखो SO3H is there, this is more stable. And after that what will come? Then there will be coming like other things, like what? Picric acid. I hope you all know that what is picric acid. It is nothing but trinitrophenol. Trinitrophenol is more than, again, OH. If there is NO2 dinitro is more than RCOOH. In RCOH also, always remember, HCOH is more than PHCOH. मतलब formic is more than benzylic, is more than any other alkylic COH is more than. Then you have to come to what to say, H2CO3, and then you can come to the phenol, and then you can nitrophenol and those things you will come later on. देखो यार, ऐसा पूरा का पूरा तुम्हें यहाँ तक एटलीस्ट तुमको ये बहुत जरूरी है. दीज थिंग्स यू हैव टू कीप इन माइंड. चलो देखो, बट हियर इट इज ओनली आस्किंग फॉर फिनॉल. फिनॉल में भी क्या क्या चीजें लगी हुई हैं जरा ध्यान से देखो. इज देयर एनी इफेक्ट हियर? नो इफेक्ट इज देयर. CH3, what it will do? It will do plus H effect. Can you see CH3 here at the para position, or you can say plus M effect. You can just say it plus M effect, no issues. Plus M effect because it is at para. Plus M will decrease or increase because it is positive effect, so it will decrease. So acidic strength here decreases. चलो इसकी बात करो. Here what is happening? CH3, it is at meta पे only plus I it can do, plus I. So it will decrease, but it will decrease by larger proportion. But it will decrease, but not by a larger portion. So acidic strength decreases, but by a smaller proportion. Here what is happening? Can you see? Here it is plus I as well as plus M. So both of them are there. So it will decrease by a largest proportion. What we can say? 4 is least acidic, while which is most? 1 is most acidic. So the correct will be, order will be 1 is more than, 3 is more than, 2 is more than 4. 4 will be minimum acidic. Why it is minimum acidic? Because it shows plus I as well as plus M. And plus I because we know that it is distance dependent. Here also you will see that it is plus I, but because it is farther, but it is closer. So यहाँ पे plus I will be stronger, यहाँ पे plus I will be weaker. it is plus m is same here also, but plus I is here stronger, so it will decrease the acidic strength by larger. It will decrease larger but less than that. Here it will only have plus I. Plus I is weaker than plus m, so it will decrease but not very much. Here acidic strength will be whatever it is as it is. Okay, next आगे बढ़ो. Which of the following order of acidity is correct? आओ देखो जरा इन सब में ध्यान से चेक करो. What we can say? As the number of carbon increases, what we can say? The acidic strength is going to be decreased. I'm telling you directly. Why it is so? Basically, here we can see that it is formic. Formic तो सबसे strong होता ही है. इसमें क्या है? इसका minus I, it will increase the for this, and इसका minus I is increased for this. So, but anyways, it is going to be most stable. It is going to be most, or you can say most acidic. Then this, and then because of this, the carbon is increasing, minus I is decreasing. हटाओ. यहाँ पे भी due to presence of more carbon, minus I will decrease. So what we can say? So maximum will be for P, then Q, then R, then S. जैसे जैसे carbon increases, directly say acidic strength will decrease. So PQRS. P is more than PQRS. Option A. Next. Which of the following compound is most acidic? Most acidic करने के लिए भाई सीधी सी बात है. आ जाओ जरा ध्यान से देखो. Now, which of the following compound is most acidic? See, here phenol is there, nitro is there. Nitro is minus M as well as minus I at ortho, because at ortho minus M works. Okay. What about this CH3 at ortho position? So ortho pe plus M as well as plus I. What about this? Can you see here there is no effect? No effect. Acha, here let's talk about CHCl3. Array, it is nothing but it is just alcohol. Alcohol, and alcohol comes in very less acidic strength. तो इसकी बात ही छोड़ो, लास्ट है वो. फिनॉल तो पहले आएगा. सबसे ज्यादा कौन होगा? This one. Why? Because this will increase the acidic strength. Here acidic strength increases by a very large. Here acidic strength decreases by a large effect. And C, acidic strength जो भी है वो होगा ही, because it is phenol and pH OH is very acidic than ROH. Any normal alcohol, you can say that aliphatic alcohol has very less acidic strength than phenol. Okay, so minimum तो हो गया ये. तो most acidic कौन हो गया भाई? Option A. If someone asks you what is the order, तो A is more than, C is more than, B is more than D. D last में ही रहेगा because it is alcohol. Okay, आगे बढ़ो. Which of the following is more basic than aniline? Aniline, देखो basic strength किस पे depend करता है? Always remember, basic strength is directly proportional to, you say that stability of conjugate acid. Conjugate acid मतलब consider करो कोई base है, after taking H plus converts into pH plus, so it is called conjugate acid. अभी जितनी ज्यादा इसकी stability होगी उतना ही ज्यादा basic strength. Now basic strength is directly proportional to electron donating effect, inversely proportional to electron withdrawing effect. Electron withdrawing effects are what? That is negative. Electron donating, that is positive. All these things. Basic strength, very important, is directly proportional to what to say? Localization of the इलेक्ट्रॉन पेयर. मतलब जितना ज्यादा लोकलाइज्ड होगा, इनवर्सली प्रोपोर्शनल टू डीलोकलाइजेशन, इनवर्सली प्रोपोर्शनल टू डीलोकलाइजेशन ऑफ इलेक्ट्रॉन पेयर. वी आल्सो can say that basic strength is directly proportional to the availability of lone pair. Availability of lone pair. Any doubt? चलो भाई इस सब के बेसिस पे देखेंगे. Aniline. What about aniline? This is aniline or pH NH2. Can you see this lone pair is in the resonance with pH? So what happens? This lone pair becomes less available due to less availability. चलो ठीक है, इसकी बात छोड़ो. Diphenylamine, N pH pH. How many of the pH are there? 1. तो इसकी lone pair की availability और भी कम हो गई because there are from two sides there is resonance. बहुत कम. Triphenyl, N pH pH pH. So there is lone pair की, this is delocalized at all the pH. What will happen? It will be even less. So all of them are very less. What about para-nitroaniline? Para-nitroaniline. अब nitro क्या करेगा? Nitro is minus M effect. And due to minus M effect, what will happen? Electron withdrawing effect is inversely proportional to basic strength. So here also basic strength decreases. What about benzylamine? Benzylamine is nothing but CH2NH2. Can you see that there NH2 has no delocalization of the lone pair because there it is aliphatic amine. It is not the aromatic, it is aliphatic amine. And aliphatic amine is more than aromatic amine. Kabhi bhi. So option D is the correct one. Always remember aliphatic amine will be more, more basic strength than aromatic. Chalo aage badho. Next. Which of the following presents the correct order of acidic acidity in the given compound? FCH, CH, 3CO. Okay, no. Acha, it is only about minus I. Can you see? F maximum minus I. Here less than that, then option C. Because F is more than Cl is more than Br is more than, no minus I. Next. Which of the following a compound is the most acidic? Okay, most acidic. ये क्या है? ये तो normal OH हो गया. No, normal alcohol. हटाओ, फालतू. It is what? Can you see that it is benzyl? It is also what? Aliphatic alcohol. Alcohol हो गया. Normal alcohol. What is this? This is phenol. This is what? Phenol. Phenol is more acidic for sure. So option C is the correct because all others are alcohol. हटाओ. Next, given are cyclohexanol. Okay. Cyclohexanol, acetic acid, CH3, COOH, 2,4,6, trinitrophenol, picric acid. ये तो है भाई बहुत strong. Okay, if it is talking about NO2 and phenol, and in these, acha, we have to tell about all these four. What is the order of decreasing acidity? Maximum will be for picric acid. So 3 will be more than. Then phenol. Second, no, sorry, 4 is more than. Acetic acid. Can you, no, sorry. Acetic acid. Then it will be acetic acid. Then it will be phenol. Then it will be cyclohexanol. So 3 is more than 2 is more than 4 is more than 4 is more. 4 is more than 1. 3, 2, 4, 1. 3, 2, 4, 1. 3, 2, 4, 1 is correct. Can be. Any doubt? Now, which of the following compound are acidic order? Okay, acidic order: phenol, methylphenol, metanitrophenol, paranitrophenol. Chalo dekho, nitrophenol, of course, it will increase the acidic strength because nitro is minus I effect. Nitro is minus I and minus M effect. Of course, you have to talk about this. छोड़ो बाकी सबको. Here OH, NO2 and और para में क्या हो गया? It is meta में NO2 here and OH. Here it is NO2. So here what is that? Minus M effect is there, while here only minus I effect is there because at meta minus M effect does not work. So what will happen? Of course, because meta minus M effect is stronger effect. So what will happen? Acidic strength will be increased more. Option D. So acha, D is more than, C is more than, then methylphenol. Methyl will decrease. Methyl will decrease the acidic strength. Phenol, but because here it is plus M and plus I. So इसकी तो बात ही हटाओ, ये acidic strength को decrease करेगा. Then A and then B. So DCAB, option D. Next is this. So the correct in decreasing order of pKa. pKa, always remember, acidic strength is inversely proportional to pKa. Let's talk about acidic strength. Maximum is for acidic strength for, it is minus M, minus I. What about that? This is minus I because it is at meta. ये क्या है? Plus M. What about this? This is minus I because it is at meta. अगर ये para है ortho पे होता, it will show plus M. But it is at meta minus I. चलो think about it. Maximum कहाँ पे हो रहा है भाई? 3. 3 is more than 4. 1 last में 2. So acidic strength is 3. 4 is more than 1 is more than 2. But pKa will be just opposite. pKa will be just opposite. So acidic strength ki just opposite. Think about it. Opposite. So 2 is more than 1. 2 is more than 1 is more than 4 is more than 3. Correct. Option A. Next, the correct order of decreasing acidic strength of the trichloroacetic acid, trifluoro and acetic acid and formic acid. Can you see what is that? Trichloro. Trichloro से क्या हो जा रहा है? Minus I effect. Trifluoro से क्या हो जा रहा है? Minus I effect. Acetic acid से कुछ नहीं. Formic acid से of course HCOOH is there. So it will be acidic but not as much because of minus I is very high here. Here also minus I is very high. What we can say? Trifluoro will be maximum. So B is more than A. B is more than A is more than D is more than C. B is more than A is more than D is more than C. Option C. Next, correct order of acidic strength. What about these all? Can you see? Nitro will increase minus M. What it will do? Plus M, decrease. But it is what? It is benzoic acid. Benzoic acid is always more stable. Doesn't matter whatever is the effect. Phenol से ज़्यादा stable होगा भाई, ज़्यादा acidic होगा. Now here it is plus M. Here it is plus H basically, not plus M basically, plus H. I'm writing plus M, but it is generally plus H effect, and plus H is weaker than plus M. तो सबसे ये तो कम कर देगा भाई. Acidic strength यहाँ पे क्या हो जाएगा? Acidic strength here decreases. Here acidic strength decreases but not as much. यहाँ पे क्या होगा? यहाँ पे भी acidic strength decreases. यहाँ पे acidic strength increases, but it is phenol, and phenol will have the always acidic strength less, and we all know that phenol is always lesser acidic than carboxylic acid. Always remember, benzoic acid से तो कम ही होगा. तो पहले इन दोनों की को पहले clash कराओ. कौन ज़्यादा? This 2 is more than 1. 2 is more than 1. 2 is more than 1. 2 is more than 1 here. Any other? No. तो यही सबसे ज़्यादा. उसके बाद 4 and then 3. See. Which of the most acidic compound? Most acidic compound, I hope you all can see that. Not a big deal. Picric acid. Next, which of the correct order of acidity? Check kar lo. Always remember, in acidity, percentage acidic strength is directly proportional to percentage S character. So Sp hybridized is more than Sp2 is more than Sp3. Can we see that? Here it is Sp. Here it is. Can you see? Sp. Here it is Sp2. Here it is Sp3. But here it is plus I effect. So option A is the correct. Why? Because here it is Sp, but here it is plus I. तो थोड़ा decrease कर देगा. उससे ज़्यादा कौन? उससे कम कौन? Double bond. उससे कम कौन? ये. I hope you all can see that. The correct order of strength of the carboxylic acid. Carboxylic acid में जरा ध्यान से देखो. Oxygen is doing what? Minus I effect. It is doing what? Minus I effect. Distance is more. So what we can say? Because we know that minus I is inversely proportional to distance. Because here the distance is more. 1, 2, 3, 4. 4 carbon का distance आ जा रहा है. तो यहाँ पे minus I effect is less. यहाँ पे minus I effect is more. तो 2 is more than 3. यहाँ पे तो कोई भी minus I है ही नहीं. हटाओ. तो minimum is 1. So 2 is more than 3 is more than 1. 2 is more than 3 is more than 1. Any doubt? Okay. आगे बढ़ो. The decreasing order of acidity following benzoic acid. Nitro. Okay. These things. Always remember one thing. What is that? Key. Whenever there is ortho position is occupied by any group, plus M minus M doesn't matter. Ortho acidic strength is directly proportional to ortho effect. Why? Because of as the nitro will be there, COH will go in the another plane, and there the here the conjugation will be so good that after removal of the H ion, it will form a very stable negatively charged. You can say what to say base. So in such case, what we conjugate base. So therefore, it will be more stable. So ortho effect is सबसे ऊपर ortho effect. So P is more. Then here it is minus M. Here it is only minus I. So P is more than R is more than Q. P is more than R is more than Q is more than S. Option B. Basic nature, I hope I have already told you about basic nature, not a big deal. Which of the following compound is strongest base? Can you see here there is delocalization? No. यहाँ पे there is aliphatic, it is aliphatic. यहाँ की बात करो delocalization, no. यहाँ पे भी there is delocalization. Option B, because it is aliphatic. Now let's go to the next part. The strongest base among the following. चलो इन सब में बताओ जरा. यहाँ पे this lone pair taking part in the resonance? No, because it is aromaticity is completed. चलो इनकी बात करो, but still we can see that this nitrogen is what? Sp2 hybridized. Let's talk about this. Here lone pair is taking part in aromaticity. So therefore this is completely delocalized lone pair. If it is, so therefore availability is very less. Availability is very less. So basic strength very less. Basic strength is very less. Here let's talk about this. यहाँ पे क्या आपको दिख रहा है? It is nothing but it is sp3 amines, and anyways it is aliphatic. अगर aliphatic है तो सीधी बात है कि सबसे ज्यादा बेसिक यही होगा. इनकी बात करोगे तो यहाँ पे भी क्या हो रहा है? Delocalization. हटाओ, बात ही हटाओ, आगे बढ़ो. Which of the following compound is most basic? मोस्ट बेसिक भाई, यहाँ पे देखो, यहाँ पे इज देयर एनी इफेक्ट, नो इफेक्ट। चलो यहाँ पर ये बताओ डीलोकलाइजेशन है, हाँ। यहाँ बताओ डीलोकलाइजेशन है, एज वेल एज माइनस एम इफेक्ट इज देयर, माइनस एम विल decrease the basic strength, yes or no? What about this? Here it is, here it is aliphatic, aliphatic, aliphatic। तो मतलब इसकी बेसिक स्ट्रेंथ क्या हो जाएगी? मैक्सिमम। छोड़ना ही नहीं, सोचना ही नहीं है। यहाँ पे भी सोचो, यहाँ पे फ्रॉम टू साइड देयर इज डीलोकलाइजेशन, ऑप्शन सी इज द करेक्ट ऑप्शन। नेक्स्ट, व्हाट अबाउट दिस, द करेक्ट डिक्रीजिंग ऑर्डर ऑफ पीकेबी। पीकेबी ऑलवेज रिमेंबर, basic strength is directly proportional to kb, inversely proportional to pkb। any doubt? चलो आओ आगे देखो। what about this OCS3, it is plus m। what about this plus h? what about this? अरे देखो, there is nothing but it is aniline, but here it is aliphatic, aliphatic, aliphatic हो गया, मतलब सबसे ज्यादा स्टेबल, सबसे ज्यादा बेसिक स्ट्रेंथ क्या होगा? बेसिक स्ट्रेंथ विल बी maximum here। okay, what about this Cl plus m as well as minus I? but always remember for halogen minus I effect is stronger than minus plus m। yes, it's the only example where minus I is more than plus m। okay, otherwise always I effect is less smaller than m। so chalo think about it, maximum basic strength will be third, so 3 is more than 1 here because plus m effect, maximum increment will be there। so 3 is more than 1, then 2, then last में 4, 3 1 2 4, 3 1 2 4, 3 1 2 4, just a minute, acha 3 1 2 4 is the basic strength, basic strength is 3 1 2 4। so pkb will be just opposite, 3 less than 1 less than 2 less than 4, so 4 will be maximum, 4 2 1 3, 4 2 1 3, option D is the correct option। it's a very good question, right? next आ जाओ, decreasing order of the basicity again is CH3NH2, okay, 6H5NH2, here it is minus I, छोड़ दो इसको, here it is, anyways it is what, delocalized, हटाओ इसको, here also delocalized, हटाओ इसको, there it is aliphatic, maximum is 1, after that 1 because there is plus m effect, due to para OCS3 it is plus m effect, here it is minus I effect, छोड़ो इसको, but still anyways it is aliphatic, aliphatic will be more than aromatic, so 1 is more than 2 is more than 3 is more than 4, because यहाँ पे at meta position CH3O minus will give minus I effect, it will decrease the basic strength। okay, so maximum will be for 1 2, 1 is more than 2 is more than 3 is more than 4, option A is the correct option। next, the correct order of basic strength in methyl substituted amines in the aqueous solution, always remember if methyl substituted is there then 2 is more than 1 is more than 3, please remember 2 degree amine is more than 1 degree is more than 3। for ethyl substituted, for ethyl substituted basic strength will be in aqueous solution 2 is more than 3 is more than 1, please remember, but here it is because it is methyl substituted, so 2 degree is more than 1 degree is more than 3 degree, so option 1 is the correct option। the arrangement of the decreasing order of the stability of these, what are these? all these are you all can see that free radicals, can you see there are 9 alpha hydrogen, here are 6 alpha hydrogen, I am writing, here there are CH2 3 alpha hydrogen and there are 0 alpha hydrogen, you can see that the maximum will be this, CCH3 is more than CH2, of course option B is the correct option। now which of the following is the most stable carbocation? most stable carbocation, because you see that 1 2 3 from 3 side there are 9 alpha hydrogen, so option C is the correct option। so that was all, that is all for this today's session, thank you class। today's session was very important because I know that GOC is such a large topic that we cannot complete everything, but still the most important parts we have already covered। now after that I will just suggest you to go through NCERT and go through PYQs and all the important type of question that you are solving,